Okay, time to measure some pistons up. So we can fit the cylinders up here. Yeah, good plastic. There it goes. First thing to do is see if you got to fit the wrist pins in the pistons. Nope, these ones fit in there all right. Once you clean the muck off, they go slide back and forth on their own, which is I want to see. I want to go see them going back and forth with gravity. So they're fine. The next thing is we got to figure out our piston clearance. So S&S a couple of years ago started putting the numbers on the boxes instead of having to go look on paperwork to find it. So here's your dimensions right here. Tell you what you're looking for. So it says 3/1000 right here. So they go out 6 digits, so 300 millionths of an inch. You don't need to go out quite that far. I'm thinking 3,000 enough. So I go to 4 digits, tenth. I don't need to be closer than that. So they're 3,000 on the nut. That's what they want to run. So that's the number we'll go with. Now, what are these pistons made to work in? These fit everything iron head, any iron cylinder. That's knuckle, pan, and shovel. 3,000. So forged piston, no skirt in it. 3,000 is not exactly tight. No, it's not exactly loose. A little on the tight side actually. But we'll go with what they say. Now, if you're worried about your motor sticking together, running really hot, like a knucklehead would be, wouldn't hurt to go to 3.5. So this guy's not supposed to be running really hard. It's a stock motor, but stock motor has to be running really hard to make it go fast. So they actually run pretty hot. So I might give an extra quarter with that one there, just to be sure. It's got enough, so I probably will do that. Because the knucklehead has iron hands, they don't cool with the crap. So might as well make them a little bit looser and make sure they don't stick. It's better to hear them and then have them lock on you. Let them rattle. Okay, so when you measure a piston, you measure on the thrust face. That's not on the side, they're out around. You measure in the middle. Now, depending on what they tell you to measure at, which they didn't tell you, you either measure them at the bottom or you measure them about a quarter inch down or a half inch down. Some pistons go all the way down to the wrist pin when they measure them, which is way down. So this one they cut the whole bottom of the piston off, so I'm going to measure right at the very top. Otherwise you can cheat a little bit. But. So just put your mic on there, see what it is. See, it's supposed to be where just enough it falls. This is a little sticky right now. Here, take the lock off. The lock was slightly on. So that's 20 1/4. So it's 20 1/4. So see, that's 20. You're about a quarter way to the next one. That's 2.5 tenths up, or 250 millionths higher. So go that way. So this one's actually a tick bigger. So this one's a half. See, it's halfway, it's right in the middle between 20 and 21. So this one's bigger. So we got a big one and a small one. So you're going to mark what they are. So this one here is 20.5, so that's the big one. So always start with the small one. It's hard to make a cylinder smaller, but you can make it bigger if you have to. 20 1/4, definitely. Now the more you hold on to the stuff, the hotter it gets. It changes on you. Okay, so if you got 20 1/4 and you want 3/1000, you go 1, 2, and 3. And I just slipped a little bit. And if you want to go a little bit more, you give it a quarter extra. Right there, you're at 3.5 on the mic. I don't really care what size it is. It's 3.5 on the line. That's all I care about. It's actually not 3.5. It's 23.5, but close enough. We find the mic we're going to use. It'll be this one. Now these are never the same. I don't even care what they are. This one's way off. So this one's at 10 to the third. Is at 23. They should be a lot closer than that. So, what did I do wrong here? This has an adjustment there where you change it. We're changing out the post. Yeah. It's in the big hole where it belongs. A little pinch screw. This has a tapered screw in here. If you go off the small hole, it's not accurate, but it should be way closer than that. I don't know why it's off so far. He's just within a couple thou. When you set it, whatever size you set it, it's accurate, but everything past that, they don't line up. So I get it where it just has a little bit of drag on it. Depending on how much drag you have on it, determines what the size is. So this one's at 0. That light sucks around here. Looks like it's at 1. And when you, whatever pressure you set that is, that's how tight it has to be in the cylinder when you're done honing it. So that's basically right on the, it's just a tick under the 1. So the reflection in here is bad, which does not help the reading of it. There's 3/4. It's nice and light. That's where it should be at. You have to force it. So you make sure you're on the half over here. You go over here like that. And I know I'm at a half. No, it's not a half. Where are we at? 3/4. That was our small piston. So I go over here and I mark it 3/4. You know this one's a 1/4 thou bigger, so this would be 1. So 1.0. That way I know it's 1, not missing a digit. And that's the number that's on the mic here. Now if you actually want to know what that is, you can calculate all out and go off that. You count these lines. 400 means 400 thou. Each full line is 25 thou. You add them all up, you get a number. So this should be 30 something. So there should be 1 line, and we're at 0. We're at 2 lines, so we're at 450 is where we're at. And this one's going to be 3/4, and that one's going to be 451. So anyway, that's what these are set at. So that's that one. So that was that mic. So now I know where it's at. All you do is grab one piston, put it by the hole, and I know what to hone to. If I want to come back and recheck it again, I can later. If I don't want to, I don't. So that's how you do that. Now these are 80-inch shovel pistons. They have a skirt in it, and they run on tighter clearance. These will go in at 74s go at 1 3/4, and 80-inch motors go at 2 thou clearance. So they have the steel strut in here, keeps it from expanding, so you can run a little bit tighter clearance. Plus cast piston doesn't grow as much as forged piston, so once again you run tighter clearance. So there you go. That's how you do this stuff. Alright, that's it for that one.